on-demand training page. So if you'd like to remain anonymous, please just hang out off camera, and that will take care of that. Next slide, please. So a few words about who we are. We're the Tri-County Regional Energy Network, also known as 3C REN. We are a partnership between SLO, Santa Barbara, and Ventura counties, meant to improve energy efficiency in the region by offering free programs and services for building professionals and households. We're funded by ratepayer dollars that we all pay into through our utility bills. And the benefit of being ratepayer funded is that most of our programming is completely free of charge. And the benefit as a regional energy network, we take these dollars that are typically distributed throughout the state and bring them to our local economy. Next slide, Larry. So we currently have 3 programs. We have our Energy Code Connect program, where we offer industry trainings, regional forums, and a Title 24 consultation service called the Energy Code Coach. The number for the hotline is here on this slide, and I urge you all to use that if you do have any Title 24 questions. We are all here today, and thanks to the Building Performance Training Program, where we offer trainings on technical and soft skills related to building science principles and systems for high performance buildings. Our goal through this program is to bring industry recognized certification and training providers to the Central Coast that'll help advance people wherever they may be at in their career. And then lastly, we have the Home Energy Savings Program, which serves households that are historically underserved with free and discounted home energy upgrades. So if you or any of your clients are looking to make energy efficiency or electrification upgrades, please check out our website for available incentives. And if you are a contractor interested in participating, there is an inquiry form on our website that you're welcome to fill out, and we will connect you with someone on the home energy savings team. That's all from me. Without further ado, I'll introduce Alex and Larry, and you guys are welcome to take it away.
Good afternoon, everyone. I'm Larry Waters, and my operations manager and partner is on the other line here. His name is Alex Sloan. He has a great deal of experience in the energy program side of the business, and I've been around the trade for a long time. We're talking about our Electrify Efficiently webinar series. Today is going to be, let's get the clicky right. Today is going to be about products in your area that are awesome and electrical products, but a little about me so you know that I'm not just some guy that's out here chatting. I've been in the HVAC industry since 1982, and anybody that can do the quick math, that's a long time. Long enough. I was actually in the trade when the first cordless drill was invented. So bring that one around, right? I've been NATE certified for 24 years, and I've had a BPI certification for Building Performance Institute since 2009, 2010. And I completely changed the focus of my career and subsequently opened up this business after I started installing heat pumps only in 2015. As you might imagine, I don't know how much you guys have contractor experience, but a contracting company that's suddenly installing heat pump jobs when they were installing furnaces before. My old boss was begging me just to sell a furnace once in a while, but I was bent on heat pumps. And then because I want to do exclusively electrification, and I had done a lot of consulting with the state and on some of the different legislation that was going on and things like that, and being a founding member on the Building Decarbonization Coalition board, I decided to open up this business that's focused on electrification really in late 2019, early 2020. We're a very mission-driven organization. Our mission is to provide the most efficient, cost-effective solutions for California homeowners, be a good steward of the electrical panel, and train and influence other contractors and industry professionals to do the same. Obviously, that last part is what's going on today. You'll get an idea of the rest of this as we present here. And one of our main practices is installing electrification on houses with 100-amp panels. And so it's not always necessary to do a panel upgrade to get electrification in your home. And we're going to show you a lot of the things that you can do today to make wiser choices to use less energy, and maybe not have to change that panel out at all in some cases. Just before we get started, a little housekeeping. The products and brands shown in here, we are not advocating for any of these brands, and they're just provided as examples. And we don't endorse, recommend, favor, or receive payment from any of the product manufacturers or distributors shown herein. But if you can hook us up with a deal, we'd be willing to talk about it. Hello. We're going to first talk about heat pumps. We can't do electrification in a house without a heat pump, right? Gas furnaces use somewhere in the neighborhood of 60 to 70% of all the gas usage in a house, depending on how many gas appliances they have hooked up. So we can't do electrification without heat pumps, and it's real easy to make a bad heat pump choice. We'll get into more of that a little bit more in a bit. But furnaces, you know, how much have they changed in 150 years? And the answer to that question is really, you know, not that much. The early days, we had our gravity furnaces. This particular one is not exactly a gas picture. It has an oil burner on it, but you get the idea. But the gravity furnaces that just strictly worked off of the heat rising technique, pulled a lot of air through a big hole and rose a lot of warm air through a bunch of little holes. And then we kind of progressed into the first fan-driven kind of operations. These are still prevalent, actually. Well, maybe not prevalent anymore, but these are still out there in our area. I should tell you, our company is in Vacaville, but most of our work is in the Bay Area. Similar climate to a lot of what you guys have. And then we went through the 70s where we had semi-efficient furnaces. I laugh when I go see one of these furnaces now and it says energy efficient or electronic ignition. And then we came up to the more recent days when we have furnaces that can get, you know, about 98% of the heat out of all the gas to be delivered into the house. But what we really haven't changed here is the combustion process and the reliance on fossil fuels. So everything is changing around us and technology is changing around us. And finally, starting in the mid-2000s, we really had heat pump technology that could perform better in a lot of ways that we look at as comfort people, but perform better than the gas furnace choices that we had to deal with, and obviously created less pollution. I started installing heat pumps predominantly in 2015, before there was an electrification movement per se, and before there was before decarbonization was like a word in the vernacular. I was just installing heat pumps because they were super cool and super quiet and really energy efficient when installed properly. And boy, I tell you, it was a hard sell back then. But everything is evolving around us. We've seen the evolution of cars come up through, you know, the Model A, which pretty much it ran on gas. I don't think anybody was calculating miles per gallon back then. I don't know. When you could only go 30 miles an hour, maybe it didn't matter that much. And then the 50s, when we had our giant steel boats with the big V8 engines and, you know, a 6,000-pound sedan. Coming into the modern gas vehicles that are very, very energy efficient in their own right, all the way up to the Tesla, which really made electric cars kind of sexy and really brought in, it brought electric cars to people that wouldn't normally have been seen riding in the old first version Chevrolet electric cars, right? Those things you saw them on the road and you were like, wow, I don't think I'd want to be in there if there was ever an accident. All the way up to the point where everybody's going, I want one of those cars. Look how cool they are. And so the same thing has happened with HVAC and other technologies in your home. It's way more, or it's way less about energy savings. All these are secondary, pollution, all this, but just amazing comfort that we can provide with these appliances and how we can change our lifestyle into something more luxurious, but also comes with really being very clean. We're going to talk about a couple of different types of systems today. And there's really two typical outdoor unit classifications when it comes to heat pumps. And one is the big square boxes that you see. Those are referred to as unitary equipment. And the reason they call that unitary equipment is because you can take an outdoor unit and match it with multiple indoor units, and it uses a common control system. So like you can have a 16 SEER heat pump and a basic air handler and a traditional 24 volt thermostat. And that would be a unitary system because I can kind of pull it all together. The mini split platform stuff is a little bit different because most of it is fully communicating, and the systems have to match. In other words, if I've got a specific outdoor unit, it needs to match with a specific family of indoor units, depending on what they are. And there's multiple types available. These units are also very unique in the way that they operate and how quiet they are. We can do conventional ducted systems with mini split. These are 3 examples of like a furnace replacement type system that we would put in that is about the same size of an existing furnace. So we can use that existing furnace location. And then we have the slim ducted models where we can really fit them into very small locations and they're quite discreet. They do the same job as these do, except we're able to kind of squeeze them into places that we weren't able to get them before. Interesting story on this one. This is a unit just like this one. This is called a slim duct unit, and it's mounted vertically. Not all brand units can do this, but this particular brand can mount vertically or horizontally. And we actually found a little alcove in this house. This is about a 900 square foot house. We heated and cooled this house with 9,000 BTUs. That's 3/4 of 1 ton of cooling. We pulled out a 24,000 BTU air conditioner with a 40,000 BTU furnace and replaced it with just 9,000 BTUs of heat pump technology. And we were able to do that because we kept all the ductwork inside the building envelope. So none of the ductwork was out in the influence of the attic or the crawl space. And then there's the ductless heads that everybody's seen before. And these are coming in more and more different ways. Most of the brands are coming out with this. This is called a single direction ceiling cassette. These type of ceiling cassettes have been around for a number of years. We see a lot of these kind of used in commercial application really creatively. If anybody's been to Nashville, it seems to be like the heating and air conditioning system of choice inside of all the honky tonk bars down there. And they just hang a bunch of these in the ceiling about halfway down. There's no ceiling actually in the building, and it's just an open space, and there's spot conditioning. And we see a lot of these heads in different environments, and these are really great if we want to just have one system controlling one room, or on a multi-zone application we'll talk about in a few minutes. And these are really great if we only have access to bring our lines and stuff up through the floor, and they don't want something hanging on the wall. These take a little bit of what we call furniture real estate. These are forehead real estate. So if you could spare the space and the lines need to come up through the floor, these are also an excellent example of a system that's quite functional for that application. Heat pumps operate in a couple of different ways. So I'm going to talk a little bit about what inverter technology is, but first to understand inverter technology, we have to understand traditional compressor technology. And traditional compressor technology, if anyone in the listening audience here has an air conditioning unit or traditional furnace, they understand that there's this kind of wave of conditioning that goes on in the house. And this diagram really shows it well in the cooling mode. When you walk into your house with a traditional unit, this would be an air conditioner or a heat pump. You turn the unit on, you set it for 75 degrees. You want the house to be 75 degrees. That unit's going to come on and take you well past what your comfort zone is. And then it's going to shut off, and it's going to let the house get hot again. And this is what we call the glide factor. And the glide factor is going to be dictated by a few different things: how well your envelope is sealed, how much different temperature differential there is from inside to outside, and how big your system is. So the bigger the system, the faster this loop and the faster the glide. So this is kind of the same thing that happens with your furnace, right? It gets a little warmer than you like it to be, and you can feel almost when it's going to shut off, and then it shuts off, and it gets a little cooler than you like it to be. So this old technology is what we find in traditional heat pumps and furnace, and it would be known as single stage application or traditional unitary application. About 25 years or so ago, some really smart people got together and invented this technology called variable frequency drive. And variable frequency drive is used a lot in big commercial products, but it was kind of adapted into this inverter-driven compressor movement that we have going on now. And so what inverter-driven compressors do differently, if you look down here on the bottom part of the chart, everything with electricity has to be within the normal 60 hertz range if it's operating as a normal electrical appliance. But you'll notice over here that our system operates well outside the 60 hertz frequency. It's because the compressors inside these units and the fans can speed up and slow down. Over here, we see a lot of energy being used to start this system every time it needs to cycle. Inverter technology doesn't need that. Inverter technology starts from a few spins and then ramps up more slowly. So we miss these large electrical consumption loads when the unit first starts. And then the unit can ramp up and it takes care of changing the air temperature in the house very quickly. And then we get into a second phase. So in order for a heat pump to work properly, we really need it to operate in 3 phases on every cycle. And this is why it's incredibly important that they get sized properly. So what we want to do is we have the air temperature change phase. And then we have, instead of passing the split or it's passing the comfort temperature and then stopping and letting the house get warm or cold again, this is just going to narrow down on the comfort temperature and slow way down. And you see these little hills here. What's happening here is called the tempering phase. And what's happening is your house was 80, you turned your unit on to 75. Well, your air temperature is now 75, but your furniture and your clothes and your countertops and stuff are all still 80 degrees. So what this does is it ups its performance and ups its capacity slightly and makes these small adjustments as it's pulling the heat out of everything in the house. And once it pulls the heat out of everything in the house, we get to this phase where it's nice and smooth. This is called thermal equilibrium. And when we get to thermal equilibrium on a properly sized inverter system, we can run multiple hours, sometimes as many as 6 to 7 hours at thermal equilibrium phase for every 1 hour at air tempering phase or the getting the house up to temperature phase. Typically on the systems we install is about 12,000 BTUs for every 800 square feet or so. And so a typical 1,200 square foot house would have an 18,000 BTU system, and that would be using about 1,800 watts here and about 250 watts here. So if you do the math in your head real quick, it can run 6 hours in this phase for every 1 hour of this phase. The way this also works different is once the end of the cycle happens, and these cycles are generally about an hour long, the unit will shut down, but it doesn't wait for it to get warm again. It just starts up at this phase again. So once your house is tempered, we're always running at these low energy phases. So this is really important because when we keep our house tempered and comfortable, our house starts working like a thermal storage battery. So if everything in the house is the same temperature, then it doesn't really matter what's going on outside as much because my house is already cool or warm. So a lot less energy needs to be used to maintain it. And so we often tell people just turn this on. If you know it's going to be cold for a week or you know it's going to be hot for a week, turn it on to your comfort temperature and leave it there. But then some people like to turn their stuff down at night and do all these things. And we recommend, like in the heating mode, that you would just like open your master bedroom window at night and keep the rest of your house warm, let your master bedroom get cold, and then shut your window and let the house come back up to temperature, because it's way less expensive to keep the house warm than it is to run the thing in full speed for 2.5 or 3 hours to warm it back up again. There's 2 different types of inverters out there that are really prevalent. There's the fully modulating and communicating inverter, and that's going to be the inverter in the technology that we've been talking about so far, which is like the mini split stuff. And then we have the temperature sensing pressure-based inverters, and that's like there's a lot of these coming on the market now, and like Bosch is one of them, and there's some other brands, but they use a traditional 24-volt thermostat. A fully modulating and communicating inverter is going to use a communicating thermostat that senses small portions of each degree and actually talks to the unit as it's moving, so we can get that tempering and that equilibrium phase working really well. These are going to be considered, the temperature sensing units are going to be considered to be unitary because we can mix and match them a bit. The efficiencies on these units are really both really good, but the great thing about the fully modulating communicating efficiency is when we are running our house at comfort level, and that thing is using like 1/5 of the capacity of full blast, the efficiencies are like off the charts. These units are always going to just kind of give you the best efficiency they can. These are they're still very good efficiencies and a good choice, but the difference is in how they keep the house comfortable. Control feature, these control based on control settings, and these don't respond to T-stat changes in real time. So one of the nice things about a fully modulating communicating inverter is if you walk in the house and you want to, and the unit's running, and you want to change the temperature a couple of degrees, you can go touch the thermostat, change the temperature, and the unit will speed up and take care of that demand right away and then slow back down. The unitary type temperature sensing units don't work that way. They use a traditional thermostat, and if you change the temperature during a cycle, that machine doesn't know you did that. So it's just going to run longer at the same rate. So back when we used to tell our kids, like, don't turn the thermostat up to 80 because it's not going to warm up any faster. That's not the case with a fully modulating communicating system. So compressor speeds on these, up to 700 points of communication with the fully communicating. And then the temperature sensing on these is usually about 5 or 6 stages, and it's going to be based on the temperature of the air that's moving through the system. No fixed airspeed on the fully modulating systems. These are always going to blow the same amount of air. All the components communicate here. None of them communicate here. Wiring from, if we're trying to save breaker space, the fully modulating and communicating inverters, they generally have one wire going to the outdoor unit, and the outdoor unit powers the indoor unit. That's not what goes on in these. The air handlers need their own 220-volt circuit in most cases. These systems have a capacity range from 20% to 130%, and these units will adjust somewhat within that, but you don't really have any control over it. So when you're hearing about inverter technology, just understand that there's a couple of different kinds, and you might not be getting what you think you are. So the advantages of the mini split inverters, the large capacity range, these units are extremely quiet. Now, all the inverter technology systems are very quiet, but these units are extremely quiet. Some of them are as low as 47 decibels. And a lot of our cities that we're working in now have noise criteria that we have to meet. And they also have like offset criteria that we need to meet on the sides of the houses. So means that these units are also very thin. When this unit is put next to the house, it only needs 20 inches from the wall to the edge of the unit. So if you're moving this onto a house that only has a 5-foot setback on one side and you're putting it out there, it's not going to be a problem putting that there because they're still going to be able to move around it. A traditional air conditioner can be, 36 inches square. So mini split heat pumps, ductless versus ducted. We love ductless, we love ducted units because they, I'll get into that a little bit more in a minute. But ductless advantages, if we're going to put a wall mount unit on either high or low or a ceiling cassette, these are really awesome. If we have one big room we need to take care of, or if we're pulling out a wall furnace and we want to just put a heat pump in that room and kind of get the same heating effect as a single wall furnace, or something like that. Or if we want to go a multi-zone where there's one of these in a couple of different rooms, these are really great for that. There is downsides to all that. The ductless disadvantages, however, is we need to really put these units on an outside wall. So when they're running in cooling mode, the water has a chance to drain outside. They also have integrated pumps that we can install on these, but those pumps do make noise. And if they fail, this unit doesn't necessarily know it failed, and it could cause a leakage problem. So we always try to avoid putting the pumps on these whenever possible. So we're always looking for an outside wall to install these on. These are a little bit more difficult for service, although the manufacturers are really working on that. One of the brands came out with a new one that you can take it apart and put it back together in 5 minutes, which is incredible because it used to take like 45 minutes to take one of these things apart. So manufacturers are working on a lot of these little issues. And you know, these are a little bit more of a tough sell for the aesthetic eye in the family. We have gotten pushback on these from interior designers and things like that. And there are some companies out there trying to come up with solutions where you can hide this behind a more attractive wooden box, but it's still a unit on the wall. The other thing about this is if you're in a very small room, this unit sticks off the wall about between 9 and 11 inches, depending on what brand you get. And that can give you kind of like, it kind of encroaches on the space of the room. These low wall units are really nice because I mentioned before, the piping can all come up through the floor, and they don't stick off the wall quite as far. Oop. Okay, multi-zone systems. So we hear a lot. We do this training program all over the state where we go out and talk to actual contractors that are working in the trades. And a lot of them, when we start talking about mini splits, are going, yeah, we install a lot of these. We install the multi-room, multi-zone thing. And they have their advantages. You can condition one room at a time if you wanted to do that. Or you can condition all the rooms at the same time. But if you're going to condition all the rooms at the same time with the standard mock-up of these systems, you have to go to every room and turn on the remote control. There are kind of advanced control packages for these systems where you can control it all from one touchpad. That gets very expensive. But it is nice for houses that have separate climate zones. Like you might have an upstairs, downstairs, and it's always warmer upstairs, or you got a big great room. Something like that is really great. There is less space needed because we don't need an attic space or an underfloor space or an area to run ductwork. So if there's no opportunity to run ductwork whatsoever, and I showed you that picture of the unit we put in the little alcove in the wall. So there is always an option if the customer is willing to deal with it. The disadvantages to these is they use a lot more refrigerant. So there's a lot of refrigerant in these systems because they have to go out to each one. So if they develop a leak, it's really a lot worse for the environment. There's also a capacity penalty on these. When we put one of these systems together, the manufacturers build these indoor wall units at certain capacity ranges. And the smallest we've seen out there is a 6,000 BTU wall unit. Oftentimes when we're doing load calculations, we're finding rooms where the maximum load requirement is like 2,500 BTUs. So by putting one of these in, it's already bigger than the room needs. And then when we install one of these, or when we design one of these, we have to count the capacity of each unit. So just take, for instance, we have these two in big rooms and they might be 12,000 BTUs. And then we have 3 6,000 BTU units. So that's 24 and 18, that's 34. We would need a 45,000 BTU outdoor unit in order to do that. And just like any other heat pump system, the larger these units get, the lower the performance levels. And then there's a secondary problem with these. These units only have the ability to slow down so far. Remember, we talked a few minutes about inverter speeds up and slows down. And so we've ran into problems with these over the years, not necessarily from us, but helping other contractors figure these things out. But when you're just running 1 or 2 rooms, and say you have both of these working and they're both 6,000 BTUs, but really the room only needs 2,500 BTUs, and this unit out here only slows down to say 15,000 BTUs, that's more than these can take on their own. So what happens is it inadvertently sends heat to one of the other zones. And if the fan is on, it'll give you unintentional heat. But the other thing that will happen is it won't allow these units to slow down enough to meet the actual load in the room, and they'll become very aggressive heating systems. So the comfort on these systems is not as good as some of the other options, but the kind of the flexibility is a little better. We install a lot of these systems. These are what we love the best. This is a single zone ducted system. And by using load calculations, we can determine exactly the size system you need for the house. And we can do multiple rooms with one unit, which means one unit outside, one unit inside, far less refrigerant. The smaller the outside unit, the higher the efficiency, and it can modulate all the way down to give us that good thermal equilibrium. We're usually installing these, and I'm not sure who's familiar with this term, but kind of the industry standard rules of thumb is 400 square feet of cooling or heating or cooling capacity for every, or 400 BTU, excuse me, 400 square feet per ton of air conditioning. So if somebody came into your 1,200 square foot house, they would tell you need a 3-ton air conditioning unit. That's very standard in our industry. So we've found on these, we can do that with half the size, about 18,000 BTUs for a 12 to 1,300 square foot house. And we can make the house use very quiet operation and extremely comfortable throughout the house. So there are some disadvantages to these. One of them is the installation slightly more involved. They need better install quality. The installers need to pay a little bit more attention to running the ductwork and using as short of ducts as possible for best operation. They will still work on bad ductwork, but they will use more energy on bad ductwork. And then there needs to be a load calc for best results. So load calculations are when they actually come in and measure each room, they measure each window, and then they put it on a manual J, a computer program, and it will tell them what the total capacity of the room of the house is and what the individual airflow capacities are for each room. That's really important to do when you're installing one of these smaller systems, so we can direct the air in the right places. These do take a little bit more time to install, but not more than a 5-zone mini split. And you have to use the correct registers with these. And so everybody take an exercise and look up the register in your room. If the register in your room has is blowing the air in more than one direction, it's not the right register for a heat pump. Great in the coastal environment are these little solutions, right? So maybe we have a small little home on the coast, or in some of the areas where we don't need a lot of cooling or heating capacity, and we just need something as a one-room option, or we want to take care of multiple areas. This is a real cool system here. This is called a gradient system. And there's actually on the outside of here, there's what looks like an outdoor unit for a window unit. But inside of here is the fan and the coil and the filter. And it just really discreetly sits in the window, unlike an ugly old, what we used to call window shakers. This is the high technology. This is also inverter technology, extremely efficient and relatively quiet for what it is. This is an Italian unit called the Efoca. And this one actually just gets vented to outside. So you can put the unit on the wall and you run these cool little vents outside. One of them brings air in, one of them takes air out. And then all of the components are in here. Your condenser coil, evaporator coil, fan, and compressor are all inside this little box. And they've really done a nice job on this. Kind of like how they fit all that stuff in a Fiat, I guess. This is a similar unit to that. This is called the Olympus. And once again, it's got European influence, but it works much the same way. And then for single room solutions, they've also got some pretty efficient, like portable heat pumps now that weren't around a few years ago. It's typical with heat pump technology and contractors to kind of do what they know. And that's, well, did I tell everybody to turn their phones off? To do what they know. And one of the things is putting in a traditional like unitary system. This is a unitary heat pump outside, combined with a furnace on the inside as backup heat. And then you have your coil that connects to the heat pump. And really in our climate, especially where you guys are down on the Central Coast, there is no need to ever have backup heat if the right system is designed. So this would be for a single speed system, and they would need backup heat. So the furnace would actually kick in when the temperature outside got below 40 degrees-ish. And then because they understand that the heat pump technology doesn't work really well under 40 with this technology. But the easy solution without this is just to put in an inverter system that has a heating capacity down below 5 degrees. If it gets down below 5 degrees on the Central Coast, which I know this was a really cold winter, but you know what? It's okay if your house doesn't heat up to 70. You're going to be okay at 65, believe me. Air to water heat pumps for hydronic fan coils and radiant systems. So these are really catching on out there with several different applications, but we want to be careful with this. If you have a customer call you or you have a hydronic heating system that's either using natural gas or oil, or one of the ones that, if it's oil, you've got an old one. But once again, with heat pumps, we're heating with a much lower capacity. So some redesign might be necessary, but there are heat pump technologies out there that will just provide enough hot water to be able to heat your home with radiant systems. And sometimes those radiant systems are going to be like a hydronic fan coil, where it's actually just warming a coil in here, and then the fan is blowing over and it's delivering like central heat. Or it could go to warm floor systems or whatever. But these solutions are out there, and they're getting a little bit more, I would say, user-friendly, but I don't think they're quite there yet. This is a great system that's available out there now, that was invented and kind of perfected by a friend of ours, and it's called the Harvest Thermal System. And this one takes advantage of the periods of time during the day when the energy is the least expensive. And it uses a really good heat pump outdoor unit that just heats water. It doesn't do anything else. And it heats water using CO2 refrigerant. So it's inert to the environment. And it heats water during the low cycles. So during the period between 9 a.m. and like 4 p.m., it'll run. And what it does is it heats up water in a storage pod, or what they call a thermal battery. And it gets that water really hot. And then when the power gets expensive, it just pumps hot water from the tank and runs it over a set of coils, and the air blows across the coils, and it heats your house like a normal central heating system. Or actually, that the coils are over here. And then there's this thing here called the Harvest Pod, and that's like the brains behind the outfit. So it's the one that's sending the water in the various different directions and making slight adjustments to when the heat pump is operating. But this is a system that's available now. It's well perfected, and they are installing them in homes today. Very, very efficient system. Unfortunately, it does need some additional modifications if you want to add any kind of cooling features to it. But there is a device that they can put on this called night cooling. And that night cooling feature, just like it sounds, it will pull air from outside at night and cool your house down, kind of like a whole house fan. So really impressive system. Geothermal, anybody heard of geothermal out there? I can't see you or hear you, so I'm going to take your word for it. The geothermal is a really good way to have a static temperature working with your heat pump system if you live in a place where the ground gets really cold. In the Central Coast area, geothermal wouldn't be likely worth the investment unless it was a massive geothermal system providing heat to a large area. For a single home operation, or just a bigger house that just has property, geothermal is going to be something that is going to have a longer payback period. And it's just really not necessary when we look at all the great air-to-air technologies that we have, but it is a great heat pump technology out there. Air source and ground source heat pumps for radiant floors, and swimming pools and hot tubs. So this is kind of exciting. So now we can take out that old gas heater that's heating your pool, and we actually have good, efficient inverter heat pump systems that can warm the pool water and keep your swimming season a little longer, so you can go out there. They're not going to get your pool steamy hot like a gas one would, and now who could afford to do that with gas? But they will keep the pool at a reasonable temperature so you can extend your swimming season. And we have a friend that has engineered one of these into a hot tub, and he's working to perfect that. But there are actual hot tub heat pump units out there. So if you really, really want to get rid of that electric heater in your hot tub, there's an option for you. You might want to wait a couple of years till it gets a little cheaper. And then there's systems out there for retrofitting heat pumps into hydronic homes. But one of the things that you can't do, if you have a house that's set up with these type of radiators, and I'm not sure how prevalent this is on the Central Coast, but there are heating systems like the Harvest Thermal with if you used a large enough storage tank, you could possibly effectively heat a house depending on what the load, but you're going to have to really, really consider the engineering on this, because most of the gas heating systems for hydronic homes are operating somewhere in the 150 to 200,000 BTU range, and we can't get a heat pump near that capacity. So you have to store a lot of hot water in order to offset the capacity loss. And then you wouldn't be able to use the cooling side for these either, because there's no mechanism in place for these to deal with the condensation that would occur when the coils inside got below the dew point. So theoretically, you could heat water hot enough and get enough capacity, but it's not something you want to do DIY or just let a contractor come in and try it out on your house. I wouldn't do that. And then there's the really big houses that we want to do with multi-zone stuff. This is called VRF technology, variable refrigerant flow. And this kind of solves some of the problems with the other multi-zone stuff where they don't slow down far enough and you can't do enough zones, or it overheats in one zone because there's not enough capacity in the other zone. These units, they actually will slow down to an nth of capacity and they will bypass refrigerant internally. So, and you can run as many as 15 heads off of one of these things. So you can have one unit outside and 15 different air handlers of various sorts on the inside. And you can get them up even bigger than that if you go with some sort of a commercial unit like a city multi here. But this VRF technology is extremely exciting. And because it's allowing one unit outside to take care of everything, and they really are extremely efficient and they modulate down really far. The other nice benefit of these is we don't need to run a line set back to the unit for each one of the indoor units. We can just do what they call like a daisy chain line set effect. So we're basically just putting T's in there and teeing off to the next unit all the way through, daisy chaining the system. So really nice system. Probably for some of those big, beautiful houses up on the hill out by you guys, might use some of this technology. All right, so that's the HVAC part. So electric water heating products. We have some alternatives to traditional water heaters that we've come across in the past, some electric, some not electric. I don't recommend these get installed, but you know, if you're in a pinch, this is probably the least efficient electric heating system that we've found. And it's really kind of a spot water heating system, and you got to use only about a cup or two at a time. This is available if a regular heater is too mainstream, or you're in a bad position with the utility company and they won't bring you any utilities anymore. This works for about the first cup of water that's coming out of the shower head. Or you can just use a hot plate and a nice copper coil and do it that way. So when people need warm water to do things with, they can get really inventive. But we don't need to deal with this. We have great systems that we can install, especially heat pump water heaters. Heat pump water heaters are really amazing. We install tons and tons of them. And traditional HVAC companies, for some reason, a lot of them don't want to get on board with this because it's just a little strange and it's a strange idea. But if you're a contractor out there, once you install these and see how well they work, and don't worry about the negative things you've heard, they're really awesome. They're an awesome appliance for the consumer. And they use just a fraction of the energy of a traditional gas water heater. And they're just awesome. So the way that these things work is there's basically a little refrigerator compressor on the top. These do work a lot like a refrigerator. They use about as much energy as a refrigerator when they're in the heat pump only mode. And there's a little compressor in here. And just like your refrigerator, when you put the Tupperware full of warm soup in the refrigerator and it absorbs the heat out of that and moves it onto the kitchen floor, this is doing the same thing, but it's removing the heat out of the ambient air surrounding the water heater. It's compressing that, or it's moving that heat into the refrigerant, and through the additional heat of compression, because refrigerant, it has a pressure temperature relationship. And as the pressure gets higher, the temperature gets higher. It delivers this high pressure, high temperature refrigerant to a set of coils that surround the outside of the tank underneath the skin. So it's not something weird looking. And that heat transfers to the water, and then it comes back cold, and it continues to do this cycle until the water tank is what we call recharged. Most of these units, if they have the word hybrid in there, it means that they have a secondary set of heating elements involved with them. And when they're in hybrid mode, they will automatically figure out the most efficient way to recover the water as quickly as possible. And so if it gets a little cold or there's a little more demand on the water heater than usual, it will use the secondary heating elements to bring the tank back up to temperature more quickly. A lot of different designs with these. And it's important that if you're getting a quote on a heat pump water heater, that you're talking to a contractor that understands the different brands and how they work. So these here are two brands that are made by the same company. This particular one here on the left is what I have in my house. This is a 110 volt plug-in model, plugs right into the wall socket, doesn't need anything other than a 115 volt plug-in. And it just has the compressor on it. It doesn't have those secondary heaters in it. Here, what you see is a internal mixing valve, and we run the temperature of the tank up to like 140, and then we mix the water temperature back down to 120. And these things are going to run for hours to recharge, but they only use a little bit of power. Like mine uses between 250 and 350 watts. And I will tell you, if you have teenage kids, maybe this one's not the best option. Or if someone else in the house likes to get up early and do the laundry on a Sunday morning and then wants to take a shower before we go out in the afternoon. If you deplete the water in one of these and deplete the hot water, it takes a long time for this to recharge cold water. That's why the hybrid mode. The hybrid water heaters are all going to need 30 amp service, except you can order some of these, like this model, in a 15 amp. It just has one auxiliary heater. Most of these other ones are going to have two auxiliary heaters, and they're going to use 30 amps of power, or they're going to need 30 amps of a circuit. They'll never use that much. But what you might notice here is we have a fan grill on the side of these. So this particular brand pulls the air in from the top and exhausts the air out the front side. This is probably not that bad because you're going to have the control panel kind of pointing out towards you. So mostly this air is going to be delivered into a way that shouldn't be obstructed. But a lot of times there's a wall right here, and that obstruction can cause a problem. This brand here is made in America. It's a really good brand. This one has top loading plumbing, which is really convenient because all the gas water heaters replacing have top loading plumbing. But the problem with this one is the exit for the fan is in the back corner. So if you have a small closet or something and you have to slide this all the way into the back corner of the closet, this brand, it says right in the instruction manual that you need 7 to 10 inches of space behind it. And that's really impossible to do if you're putting this into a lot of applications. This brand kind of answered all these questions. This is a brand that's been building these for a long time. This is their I think 4th iteration or 5th generation of this system. And they really went to contractors to say, what are the problems that we can solve? And they solved a lot of them. One of them is they put the plumbing on the top or the sides, so you can make the choice of whether you want to plumb out the sides or the top. And they also put the fan intake and exhaust on the top. So there's no requirement for this thing touching walls on 3 sides. And they put these little connectors on the top so we can easily hook the duct up to this and just vent the air right out the side of the closet. This one also has an advanced control package on it that really gives you great functionality. Most of these units are going to have control functions where you can cycle them off for certain times during the day. And if you're going to put one of these units in a closet, you really got to think about that. Okay. Installers should be trained. DIY on heat pump water heaters are not something that you should consider. There's a lot to be done on these, and so in turn, there's a lot that can be done wrong. And we've had more than just a few calls of people that like, I got this heat pump water heater, I have it in my garage, can you come install it for me? Once I opened the carton, it looked like it was too complicated, and it is. This is a complicated install for a homeowner. And something that needs to be considered on every single heat pump water heater call is how quiet is your customer's lifestyle. This is a big problem we hear about a lot. We don't hear about it a lot from our customers because we talk about it a lot. But these systems do run for a long period of time, and they make a sound that wasn't in the house before. And if you put one of these things in the wrong spot, the sound can kind of resonate through certain areas. And so it's really important to talk to people about the sound that these are going to make and just warn them about it. If there is a customer that says, I really want a heat pump water heater, but I don't want any noise, there's a solution for that too. This is called a SAN CO2, and this uses CO2 as the refrigerant. The noise making unit, which is extremely quiet, is outside, and we just do the plumbing to the indoor tank. So the tank plumbs into, or the heat pump plumbs into the tank, excuse me, and then you have your domestic hot water that plumbs out. And you notice down here, there's a little mixing valve. This unit is going to constantly keep this tank at 150 degrees. These tanks are pretty narrow, depending on what you're looking at. But they have a 43-gallon tank that's only 38 inches tall. So if you need to stash this thing under somebody's house or a deck, this unit can also be mounted outside. It's not like a traditional tank top heat pump where it needs to be inside an enclosure. So we do have some of these out there where the sandon is here and the tank is right next to it, sitting on the side of the house. So that is possible as well. So super flexible on this one, no sound, and you don't have to worry about a tank that doesn't have mechanicals. These tanks are, I think, warranted for 15 years. A nice feature of this system too is it only needs a 15 amp breaker versus the other units need 30 amp breakers unless you do a special order 15 amp model. 37 decibels is what you're going to get out of this unit outside. And this uses an inverter compressor. So it only uses as much energy as it needs. So if you only use a little bit of water out of the tank, it's going to use much less energy recharging the tank. Then there's electric tankless. Oh boy. We get calls about this all the time. Like, I have a tankless water heater. I want to put in a new water heater. I want to put in electric tankless. And these are not practical in any way. It takes a lot of energy to heat cold water to a reasonable temperature that you would be satisfied with in a shower. And when it's in wintertime, the water coming through the ground is colder, and they even use more energy. So typically these systems, you can see all these wire connections. These are going to need 3 40 amp breakers to run this unit. So you would need 120 amps of available power to run this. And this thing will ramp up to a full 120 amps once the, well, it doesn't really use that much, but it does use a lot of power when the water's cold and the demand is high. Something like this in a smaller version might be able to be used in an ADU, but you're gonna have to like trade off energy points. But realistically, electric tankless water heaters in California, not practical. And California will only let you purchase one of these that's under 12.5 or 15 kilowatts. So that's really not enough to have any two loads going at once for sure. All right. That's the part with the heat pump water heaters. Now we're going to go into electrical panels. And so we get this problem a lot. Like, if we're going to add a heat pump water heater circuit to this panel, now in this panel, we have a number of challenges. We have a lot of arc fault breakers that take up more space. We have several 2-pole breakers here, and then we got a lot of quad breakers here. So there's already a lot of space taken in here. So there's not really a lot of opportunity to expand this, but it doesn't mean this panel is at capacity. So these are all small amperage breakers up here. And we'll go, I don't think this slideshow deals with the load calculation. So, but when we load calculate a electrical panel, we find a 100 amp panel has 24,000 watts of capacity available. There have been studies that have been done on these. They found that out of a study of 20,000 homes in the Sacramento area, they found that none of those houses, or like 95% of them, never went over 88 amps ever. So a 100 amp panel is usually enough for everything you need. So how would we add a heat pump water heater circuit to something like this? First thing we would do is maybe quad it out, put a quad breaker in there and split the circuit. We might install a circuit splitter. These are really cool devices. These can be used in houses. We use quite a few of these every year. And what you see here, this one on the top is easy to explain. This plugs into like a dryer outlet. And you can plug the dryer into one side, and you can plug a car charger or a heat pump water heater into the other side. And this is a precedent unit. So it has a primary output and a secondary output. You would plug the heat pump water heater into the secondary output side, and the dryer would be plugged into the primary output side. And so anytime you're not drying clothes, you would be putting power to the secondary side. And then when you turn your dryer on, it's gonna turn off enough power for the motor to run on the heat pump water heater. The heat pump water heater will still, the control panel will still have power. It's very interesting technology, and it's available in a couple different things. This is called a smart switch, I believe. And I can't remember exactly the name of that thing. But this is a hardwired version of the same thing. So you can actually bring a wire in out of the breaker box, put it here, and this senses total load. And it can sense two ways. but it'll just like switch the circuit off if the load in the panel gets higher, or it'll take precedent one over the other. And then the dryer buddy, this is one here that's kind of programmable, does the same thing. Or we can add a little sub panel, right? We can use that dryer outlet, and then we could just put a breaker in there, run a circuit over to a sub panel, put our dryer wire in there, and then run our additional appliances off of that. We do want to make sure that we optimize this. And always, if you're going to run a sub panel, you need to add the neutral, because if you don't add the neutral, it could cause a shock problem if anybody ever hooked 110 load to this. And believe me, there are homeowners out there that see these open spaces and they want to run a plug to their shop or something. They're just going to hit that thing up and not realize that it's not grounded to, or that the neutral is not put in. So if you don't land a neutral in this, you need to write on here, no 110 volt loads. The other option is to go with a smart panel. Like if everything else is exhausted and we really want to upgrade and get into a new level of technology in our electrical systems, we can do a smart panel. There's a couple of really cool brands out there. This one that you see on the left is called a Leviton, and we call this the dumb panel with smart breakers, because each one of these breakers has its own Wi-Fi capability, and it kind of integrates into a hub, and then that hub communicates with the app. And then you have the span panel, which is basically a smart panel with dumb breakers. And so all of these can do different load shedding characteristics. You can set them up to take precedent one load over another. Excuse me. So that's also an option. These also have sub-circuit energy monitoring. So those are the solutions if we just want to add to an existing panel. If we want to watch what we're doing with electrical, we can put one of these cool sub-circuit energy monitoring systems in. We use a lot of these Emporia systems here at our office. We install a lot of these on customers' houses, but there's a bunch of them out there. I have a curb personally in my house. I like it a lot, but it helps you just see where your energy is being used and make adjustments in real time. So any questions about any of that first part? We'll just go into questions real fast, and then we're going to jam right into the second part because we got about 35 minutes, it looks like.
Larry, we got one question. There's been some good activity in the chat, but let's bring up one that came up from Kristen. What would it take to electrify a gas furnace in a mobile home, or maybe just some general guidance for mobile home electrification?
Well, mobile home electrification is going to be the same as anything else, only we have the park power to worry about. Like, so wherever that mobile home is, there might be some sort of limitation on the power coming into each unit, but it would still be wired in the same way. And we could still run, most of those have like a gas furnace that's kind of built into the wall, and a heat pump air handler can be put in that same space. And then the return air would have to be modified a bit. And then we just put the unit outside. So it can be done the same way. It just needs to be done with a load calculation and a little bit more awareness to how much energy is coming into the mobile home itself. If that's it, we'll trudge on.
Yep, let's keep going on, and then we'll stay on afterwards if there's some additional questions.
Perfect. So other products, this is where the cool fun stuff is. The other stuff was all business, like heating and water heating are the most electrical load in your house. So those are the important things that we need to get right. And that's why we spend so much time on that. This next part's kind of the fun part. So first of all, stoves. I don't know why it is, but stoves likely get the most pushback from a customer. And really, there's the most direct evidence that stoves cause indoor air quality problems. And it's the one that most people have pushback on. Getting some people away from their gas range is like taking a phone away from a teenager. There's tons of evidence and studies out there that would indicate that your gas range is polluting your air. And really it is. We think about all these things that we do in a house to make your water heater exhaust go out safely, and your furnace exhaust go out safely. And we're really worried about what all this exhaust is doing to the environment. Yet we have a gas stove in the house that has no real exhaust capability other than the fan on top that most people never turn on. So there's the most reason why you would want to install an electric range. And once again, technology has gotten us to a good place. There's the old electric resistance ranges, and even the kind of the fancy ones with the glowing black tops here. My friends have one of these in their house. For whatever reason, they bought this rather than an induction range because I think they thought it was one. But these things can stain up. This surface gets extremely hot in order to transfer the heat to the pan. And so if there's any kind of foreign object on here, food or anything like that, it will actually cause this thing to burn and scar. So that's not too great. But the thing we have now available to us, that's really my dad, when I was growing up, owned an appliance store for 40 years. And when I told him I got an induction range, he said, you know, they had those things in the 50s. So the technology has really come to where it's nice enough now that everybody can take it. And I have this exact model in my house. I took advantage of a moment of weakness with my wife when she was complaining about cleaning the grates on our gas range again. And I said, hey, let's just go to the appliance store and look at a new gas range. And I kind of shoot her over to these and I go, look at this. And I got her to buy the first day. And we came home with this in the back of our truck. I knew my house was pre-wired for the range. So we plugged this thing in, and kind of the first response is, how am I going to cook my tortillas on this? And so, but that's so far is the only negative response we've had. And we did figure out a way to cook our tortillas. We just put the tortilla right directly on the burner and we stick a big pot right on top of it, and it warms up the tortilla better than the flame ever did. But the way that these work is it's through magnetic pulse. So the top of the stove never gets hot. There's just these magnetic rings in here. And the magnetic pulses spin through here, and it excites the molecules in the metal of your pan. The one caveat with these is you do need a stainless steel or you can use grandma's old cast iron, or you can use any pan that has the right base on it. And these are going to heat very evenly and very quickly. Like with this unit, I can boil 6 cups of hot water on mine in about 92 seconds. More hot water takes longer, but we did a side-by-side comparison. Before I pulled my old gas range out, I warmed up I boiled 6 cups of water, and it took me 4.5 minutes with the gas. I put it on my new induction, got it done in 92 seconds. So it cooks very fast, which is good and bad. When you're learning about these things, it's not great because you don't want to turn your back on the sauce, or it's going to turn into more of a caramel. But you just got to keep your eye on it while you're cooking on it. But once you get used to cooking on one of these things, they're magnificent. And a great thing about these is, since there's no heat conducted off the top, it's just the pan itself heating up. One of the tricks that we do is, if I know I'm cooking something that's going to boil over, I'll just put paper towels right over the burner, put the pan right on the top of the paper towel, and then when it boils over, the paper towels are there to absorb the boil over. So it's really nice and easy to clean. And after 2.5 years, or going on 2.5 years with this thing, the top looks like brand new. It's amazing. These things are available in a bunch of different cost electric ranges. We can get electric ranges out there for as cheap as $450 now. And then you can get into the mid-range, which is like the induction ranges. These are going to cost a little bit more money, but the cooking with them, because you can cook faster, and you don't have to heat that element up. They do use less energy, but they require the same outlet. And we've cooked a full Thanksgiving dinner with 4 pots going and all that. And that thing was pulling like, I don't know, it was pulling like 3,900 watts or something, but it was quite a bit of power, but it did it flawlessly. And most of these electric ranges are going to give you some treats, like built-in air fryer, convection, convection broil, convection bake, and convection roast. So there's a lot of nice cooking techniques that can be used with these electric ranges that you can't necessarily get with gas. And then there's no pollution. It's a no-brainer. So good that I don't know who loves Taylor Swift, but apparently a lot of people, because you couldn't get a ticket to her concert. But if you go on YouTube, you can watch her sing one of her songs while she's cooking something on her convection range. So there's also convection cooktops that are available in various sizes that are really nice too if you have a gas cooktop. Really, gas stoves is like smoking cigarettes in your house. There's a lot of heat that comes off of these, but with that heat, we talked about that a minute ago, all the stuff that our gas water heater and our gas furnace is taking outside carefully through the flue pipes is just coming right into the house here. There's been a lot of studies, and you can't contest these studies because some of these studies are like 13 years old about the dangers of gas ranges in a non-well ventilated space. And really, if you have a microwave hood above your range and it doesn't exhaust to the outside, that's not ventilation. You're just moving the air around. And if you have a microwave hood that does exhaust to the outside, it's not that much better. Those don't work that good. So if you have a gas range, just always run the fan no matter what when you're running that range. So try to remember that from now going on. Outdoor entertaining, heat, and barbecue. So if you're going to go so far as to not buy propane anymore, they've got these great electric heaters that can put out as much heat as the propane ones. The nice thing about this is you're not going to run out of propane in the middle of the party and have to drive down to Walmart after you've had a couple of cocktails, right? So I've never done that, and nobody at my parties have ever done that, because I make sure that I stock up with extra propane bottles. But I will be buying one of these FireSense heaters so I can just plug that sucker in and not worry about it anymore. There's also a bunch of the barbecue people are coming out with electric grills, and they're even working on battery powered backup ones. So a lot of good stuff there. Who doesn't love a good fireplace with great ambiance? I mean, come on, it's wonderful. But how are we going to have an electric fireplace? I mean, there's no flame there. So people have come up with a reason or solutions for this too. This is a really cool thing here, the Dupli Optimist. So it actually uses a tank of water and a misting system, and it gives out microparticles of moisture that kind of are excreted behind the electric, and then it uses a light array of these perfectly balanced lighting coming up through the steam, and it looks a lot like regular fire. Now, you've never had to change a light bulb in a fireplace before, so that's part of where we're going with this. But man, the great options for all these stuff. So we can still have a nice fireplace in the house that looks like real fire, that is actually just electric. So how about who does laundry here? Everybody do laundry? So laundry, if you have an electric dryer in your house, that thing can use 7,200 watts, an electric dryer, a 30 amp plug, 7,200 watts, which if you chose a more efficient drying system, you could actually charge your car with that 7,200 watts and just, I mean, the correlation is interesting. Anyway, so you can drive, for every 1 hour of charging, you can drive 30 miles with 7,200 watts in your nice electric car, or you could dry a load of clothes. There's different types of these units. This is a resistance unit with heat pump, and you need to plug it into a standard dryer outlet, but most people are just going to get like a standard plug-in electric dryer. They're going to need the same amount of kilowatt capacity range. They may never use it, but then we also have heat pump dryers, if anybody's heard of heat pump dryers. And then there's the even more efficient condensing dryer combo, and the power demand on these is really small. So heat pump dryers and condensing dryers can actually be plugged into a 110 volt outlet. And if you think about the power of that when you're trying to electrify a whole house, if I can use that double breaker space for that from the dryer to run my new heat pump water heater or run my car charger or something like that, just by changing over to a 110 volt dryer, that's a game changer if we're trying to electrify a home on 110 volt outlet. So this is what the dryer cycle looks like on a condensing dryer. And basically what it has, it's got a heating element up here. So it does use electricity to heat the air. And this is going to be the one that uses a little bit more energy. So it heats up this element here. It doesn't exhaust the air to the outside. So it continues to circulate the air in here. It's slightly warm here. That warm air is going to create it's going to pick up the heat as the moisture travels on the heat. And then it comes up through what they call a condenser plate. And this condenser plate is just basically a bunch of round plates in here that are kind of sitting at room temperature, and they're below dew point because the air is warm. So they just collect the moisture out of the water as it goes through, and it just continues to do that. And then the water just goes down the drain. A nice feature about these type of dryers is they don't need to vent to the outside. So traditional dryers are really nothing more than a 150 CFM exhaust fan with a heater built into them. So you're really moving energy outside your house anytime you're doing that, if the washer dryer is inside the envelope. So these can also be much more energy efficient because of the impact they have on the negative pressurization of your home. So these are kind of cool. So these are all in one. So this is what Europe is doing a lot of, and they want one appliance. So these particular combos, we see this one here is a condensing unit. So a condensed dryer, just like we showed you, but it also has a washer built in. So all of these are washing the clothes as well as drying it all in one unit. And the way that they do that is they're able to wash the clothes just like a normal washer would be, but they have a more aggressive spin cycle. So they're moving more of the water out of the clothing before the dry cycle starts. And then it automatically goes into the dry cycle. Now, these are going to take a little longer. So if you have a lot of laundry to do, we're talking about a 2-hour cycle on these. But if you think about at my house anyway, we put the laundry in, it's a 22-minute cycle. We go about our business. We remember it an hour and a half later. And then we go take the laundry out of the dryer or washer and put it in the dryer. We put the next load in, and then we turn the dryer on, and the dryer runs for a little while, and we forget about it, and we come back 4 hours later anyway. So we're really getting a load of laundry done every 2.5 hours anyway. So one of these, you put it all in one, you come back, and boom, you got dry clothes coming out the other side. It's amazing. But what about efficiency? So there's the condensing dryer and there's the heat pump dryer. So condensing dryers, because they're going to use a heating element, are always going to use a little bit more power and be a little less efficient than a heat pump dryer. And a heat pump dryer is going to use an actual heat pump, just like a heat pump water heater does. And that heat pump, that heat, I'll go more into that in a second slide here. But the heat pump, actually, we showed you on the condensing side that the air goes across the collector plate that's kind of at room temperature and because of dew point. But the heat pump dryer actually has a hot or a cold coil and a hot coil. And so the cold coil, because it's well below dew point, it collects the water out more aggressively. So it condenses more water out. And then as the air travels from there, it goes back through the exhaust side of the heat pump and warms the air up again. And then in a hybrid one, it'll actually have a third electric heater that warms the air up again. So there's a bunch of different options with these. This is the highest efficiency heat pump dryer. This thing is 10.14 CEF efficiency, which is really good. And I apologize because CEF is escaping me right now. But except it's the combined energy factor. It shouldn't escape me. It's right on the slide. So 10.4 pounds of water removal for every kilowatt hour of energy. Pretty good stuff, right? So estimated annual energy use on this unit is 236 kilowatt hours. Let's just round that up to 250 and call 30 cents a kilowatt hour. That's about $150 a year to dry your clothes. Pretty cheap. GE Profile this year, they came out with this cool one, and it's an all-in-one solution with a heat pump, a backup electric, and a washer all built into one unit. And this unit also is a 110 volt plug-in unit. So all of these options can be ran off 110 volts. We've now brought that 30 amp circuit back into play, and that's going to help us electrify something else in the home. Does it save to purchase one of these systems? Like most of the time when people look at these, like, oh, that's ridiculously high price. But if you look at a combination washer dryer price, those are anywhere between $800 and $1,600. They do have the new one that I just showed you that's like $1,900. But if you go out and buy a new washer and dryer combo, like a decent one that's going to have the same feature set, that thing's going to be around $2,000, right? So I noticed one the other day when I was at Home Depot, it was on sale. The dryer was $795 and the washer was $995. So that's $1,800 there, which is more expensive than the single appliance. So it is less expensive to buy one of these. Because you're getting the washing and the drying in one unit. All right, so one of the things we're really worried about now is power transfer and batteries and solar and all these fun things that are at the top of everybody's mind. But what would be cool if we could harness the giant batteries that are in the electric cars? And a lot of the technology is moving towards this. And there's these different alliances that are being made between manufacturers and charging manufacturers and things like that, that are looking for car to home. So we can transfer, like in an emergency, we can power up our house with our F-150. But we're also looking at things like the wall box or the decibel. The decibel is an interesting product. This is going to give two-way DC charging, but also be able to use the car as a battery. And they're working on technology where they'll be able to upload that power into the grid during off cycle. So if you work from home, you could charge your car up during the day, and you could have your car put energy into the grid when power is expensive and offset all your evening energy use. And you could end up selling power back to the grid. Oh man, who doesn't want to hear about the Tiaga snowmobile? You guys could have used these up in Big Bear a couple of months ago, right? We had a lot of snow this year, so snowmobiles is kind of a cool thing. But these are electric snowmobiles. Tiaga is building these and some other cool toys. And how cool is it, like, if you're out snowmobiling and you run out of gas, or you worry about fuel, or you hear the noise of the snowmobile, if you could just go out there and have a full battery, and you could snowmobile for 6 or 7 hours, and you don't hear any sound, and you're one with the environment. And these are great for hunting and stuff, because you're not scaring off all the wildlife on your way out there. I can see some downsides of actually having a super quiet snowmobile, like the other guy coming up the other way, but terrific technology that's coming out there. And the jet skis. You know, the one thing more annoying than a jet ski is the sound of one coming up behind us when we're on our boat, right? It's like having a Harley come up behind you in traffic on the highway. But these jet skis have faster response time than a traditional jet ski does. You don't have to go to the gas pump, and you can ride one of these things for 4 or 5 hours during the day on a single charge. And you know, there are some people that might ride their jet ski more than 4 hours in one day, but I was never able to. But the technology is here to do this. Like, ultimately, you could take this back to the dock, plug it into your boat, your big boat, or the dock, and charge it up for a day, come back the next day, you got a fully charged jet ski, take it home, charge it up over the night, bring it home. But you don't have to worry about oil, you don't have to worry about maintenance, you don't have to worry about sound. It's just an amazing, it's an amazing time to be embracing electrical fun things. The Rambo hunting bike. So this is pretty cool. This is an off-road bicycle that's designed to go out and pull a heavy load. So this bike has a torque mechanism built into it. Like, you can tow a trailer behind it and haul a 800-pound deer with you. But the nice thing is you can sneak up on your prey as well. So you can ride this thing into the forest, and all they're going to hear is the little pieces of wood crunching under the tires. No motorcycle sounds or anything like that. And if you're super into it, this would be a cool thing to get into. All right. So anybody out there, raise your hand if you got enough money to drop on one of these bad boys. But there are some people in the 3C RIN area that probably have one of these in their 20-car garage, right? This is the Rolls-Royce 103EX 4-electric motor, artificial intelligence chauffeur. This car will come get you. It'll drop you off, and it'll bring you there in more style than you ever thought. I have no idea about the details of how much this costs, but I know it's a lot, and how long it goes on a charge, but I'm sure it goes really fast, and you are going to turn some heads in this baby. If you have the means, I would suggest buying one of these, or maybe renting it. And if you have that, you probably need one of these. This is the silent 120-foot solar yacht with the XP4 electric helicopter. This has been in production for a number of years now. This system right here is totally autonomous. It has a battery system big enough to take it wherever it needs to go, and it's fully rechargeable with solar. Don't ask me what happens if you get out and you don't get any sun for a few days. I didn't do that much research on it, but I'm just hoping that somebody on this call might know somebody that can invite me out on this thing and get a ride. And if you've got this beautiful electric yacht, who doesn't want the submarine to go with it? So the U-Boat Works Silent 120, the electric personal submarine. If you're looking for a gift for that guy that has everything, this is one way to do it. Get a couple of your friends to go down to the deep dark lane and grab that champagne bottle that you accidentally dropped over the side of the boat. So pool heat pumps. So we have the ability to heat water with heat pumps really well. This pretty the Tamarack Club up in New York, Ellicottville, New York, by the way, they're able to use their heat pumps to heat all 5 pools in the summer, and they can intensely heat the hot tub and 1 pool in the wintertime. And so when they installed these heat pump systems for the pool, they saved over half of their energy cost in the first year. So they were talking about the entire system was going to be paid for in just a short number of years. And they're able to do it cleanly, and they're not at the realm of incredibly high fuel costs rising. So if we put our minds to it, we can do a lot with electric, including work 24 hours a day. So a lot of times in Europe, there's a lot of tractor companies that are building fully electric tractor systems. And what these are really good for is extending the workday. In a lot of the country, we have times where we have to not have any noise. And if you're able to extend the workday because you can work silently through the night and not pollute, it's an incredible game changer there as well. And all of these things are available in electric, as well as the wonderful. This is a new thing that's coming out. The Ocean Bird will be delivered in 2024. This is 90% offset of fossil fuels in transatlantic shipping. And so transatlantic shipping stuff over from China and bringing it over here and unloading it, and us using it for 2 years and throwing it in the landfill takes a lot of power, right? It takes a lot of gas or whatever fuel. And so these ships are actually being built with these hybrid wings built onto them, so they can deploy these wings and actually propel the ship with wind when their wind is available. So we're going to make use of a natural resource to push this thing through, and it's going to reduce the energy use by these ships by up to 90%. It's pretty darn exciting. Airbus is working on zero emission airplanes. I'm not going to ride in the first couple of these, so the jury's out on me taking an all electric plane flight anytime soon. I'm going to wait and see how that turns out. But man, when we can think about having enough energy storage power that's light enough to be able to propel engines to drive a craft like this through the air is really just amazing. Where are we getting on all this on all this technology? So coming to an airport near you. Yeah, I think it might take a little bit longer for these to fuel these up at every stop. I'm wondering how that's going to work out. So that's us. I think, are we on time on this thing?
Yeah, I think so.
All right, very good. So any questions we have on any of that stuff or any of the stuff from before, we'd be happy to field those. I think we came in right about on time, right?
All right. If there's any questions out there, feel free to unmute or put it in the chat. We'll stick around for the next 5 minutes or so.
I can run through our just quick closing slides while we hang out and let people think of some questions if they'd like. Larry, do you mind advancing?
Oh, you got it. All right. Here we go.
Thank you. We did have AIA learning units available for today. We had 1.5 LUs. So we should have everyone's AIA number if you inputted it in registration, but if you did not, you're welcome to reach out to me personally. My email is here. We will share slides, the recording, and a survey for today's webinar. All survey results are really appreciated and help us kind of work towards bettering these offerings for you all. So thanks in advance. And then, yeah, I would say at this point, we have events at least once a week from now until June, and we're about to finalize our Q3 calendar as well. So please feel free to check out more events on our website, and then our additional resources for Code Coach and our home energy savings program are listed there. I think that is all from me, but yes, if there are any questions or any thoughts out there that weren't addressed, we'll hang out for a few minutes and attend to those.
Yeah, thank you guys very much for attending, and I hope everybody learned a little something. We are available if anybody has any questions, or they can, like if you're looking at designing a system, you need help with some of the information, with getting the heat pump sized right, or you just want to ask some questions about how you're going to electrify your home. You can call our office and we can schedule a time and have a chat with you if something's necessary there. And we're really excited to do these for 3C Ren. And I hope all of you come back with all of your friends next time. That would be fantastic. Any last questions? If not, I'm going
one more
Yeah.
coming through the chat. Why has the industry gone over to heat pump water heaters rather than the dinosaur, but super reliable rooftop solar hot water?
Well, yeah, I think Alex, you already know what my answer is going to be on this. So the rooftop solar is a cool way to do that. But, you know, a lot of people installed rooftop solar back in the 80s and early 90s, when there was these really big federal incentives that came out, and people built their businesses around installing rooftop solar, and then the incentives went away and then nobody was installing it. So like people got stuck with nobody to work on their rooftop solar systems. And then when we put a heat pump water heater in, we can just put two additional electric solar panels up, and that'll run that heat pump water heater for the year. So if you already have solar and we want to keep that primary roof space for generating electricity, because we're going to have to move a lot of things over to electric, then the roof space is better used for photovoltaics. But also we don't have to go like drill through a roof, which is a big deal, right? And then you have a big storage tank and a second tank, and so there's a lot to the solar water systems that aren't necessary. And when a solar water system dies, there's like a lot of pieces that need to be dealt with. This thing, when the heat pump water heater dies, you put a dolly on it, you roll another one in. So there's a lot of reasons why these units are a little more user friendly. So that was a long answer to a short question.
Awesome. Well, we can close things out there. Larry, Alex, thanks again for today. That was terrific, and trying to make electrification more practical in a lot of our minds. I think the Rolls Royce threw me off a little bit, but always fun to look at stuff like that.
It's amazing how long luxury has been electric, right? I mean, it's being adopted really big in the luxury side. So we can all attain to stand next to one of those in a parking lot someday.
Awesome. Again, my information is available. I'll share out slides and all that good stuff, but you are all welcome to head out and enjoy the rest of your evening.
Thanks, everyone.
Thanks, y'all.